Welcome to Chapter 10, Lesson 2. We're talking about liquids. So in the first lesson, we went over kinetic molecular theory and applied that to gases. We're still going to be discussing that, but today we're going to apply it to liquids. All right, so let's get started. You should have a copy of the notes. Let's get started with liquids. So in terms of the forces that are acting between the molecules in a liquid, the particles are still constantly moving. Okay, they're closer together than they were in gases. So those attractive forces that are acting between them are stronger. Okay, so with gases, we said there's basically no attractive forces. With liquids, there are some attractive forces. They're just not really strong. Okay, so liquids are fluids. They can flow. The particles are moving constantly, so they're able to move past each other, but they stick together a little more than they did with the gases. Okay. So one of the things that your book really focuses on is the physical properties of each state of matter. So where gases had a relatively low density, liquids tend to have a much higher density. The particles are packed more tightly together, so they take up less volume. So you would have a greater density. Remember, density is the mass divided by the volume. So for the same mass of substance, you would have far less volume, so you'd have a greater density. The density of different liquids, though, of course, is going to vary a lot, just depending on what substance you have. Okay, and that's how we can form. If you guys have ever made one, and you should have, when we did biology, made a density column where we added different substances to a graduated cylinder. So it's like corn syrup and vegetable oil and water and rubbing alcohol. And so everything has some food coloring. You pour it in and they form these different layers. So the most dense layer is going to be on the bottom and the least dense layer would be on the top. Okay, so liquids can form those different densities and create that column. Liquids are relatively incompressible. So gases, we can really compress them because there's so much space in between the molecules. But liquids can't. Those stronger intermolecular forces are holding everything much closer together. They're still moving around and sliding past each other, but they're so much closer together that we can't really compress a liquid. Okay, we can't squeeze it down anymore. So, for instance, liquid water, we can only decrease its volume by about 4%. And that's so the conditions that they did that was 20 degrees Celsius, so about room temperature. And they added a pressure of 1,000 atmospheres, which is kind of a lot. We'll talk about pressure units, but it's a pretty decent amount of pressure. So the liquid is only compressing about 4%. You're only able to decrease the volume by about 4%. If you do that to a gas, if you add that same amount of pressure, then it would actually decrease by about 1/1000th. It would have the dense or a volume that is 1/1000th of what it was original. Okay, so gases are very compressible. Liquids are basically not. Okay, liquids, much like gases, can diffuse. This is why if you take a beaker of water or a cup of water or something and you add a little bit of food coloring to it, eventually, if you just let it sit, the food coloring will mix all throughout that water. Okay, that's diffusion. So liquids do have the ability to diffuse or mix together. It is much slower in liquids than in gases. Because the particles are so close together already that they kind of have to work themselves in between. And then the attractive forces of the particles of the liquid, right? So now we're close together, we're sticking together a little bit more, so that slows down the diffusion. Liquids have what we call surface tension. So all liquids have this force that's pulling All the molecules that are at the surface of our substance, they're all pulling down, okay? Or they're being pulled down by the layer below. So the idea is to decrease their surface area. So that is these attractive forces between the molecules of the liquid are pulling everything down. Different liquids have different levels of surface tension. Water's is higher than most, which is important for life and things that need to float on the water or walk across the water, things that live on the water. So that high surface tension is really important. That's also what causes water to take on that bead shape, that spherical shape as it falls. Or if you have a drop of water on the surface of like a table, it forms that curved structure. That's because of the surface tension. Surface tension also leads to what we call capillary action. And so capillary action is what will cause a liquid to rise up a very narrow tube. So this is important for like plants, like getting water up to the leaves. But that's related to that attractive property that leads to surface tensions. That same principle leads to this capillary action that as the water molecules or whatever liquids you have start to move up the tube, they kind of start to climb up it, they pull on all the molecules behind them and pull them up with them. That is also why we get a meniscus when we look at a graduated cylinder. Remember, there's that dip. That's because of the surface tension pulling down on those particles. Okay, so above, if you get water up above the surface of a cup or something, it forms that little, forms a bow shape, right? It kind of bubbles over until you get too much and it all spills out. But if it's inside, especially like a cylinder shape, it forms the opposite shape, more of a bowl. Okay. Liquids go through evaporation and boiling. So evaporation and boiling are related, but they're not the same thing. They fall under this category called vaporization, which is just turning a liquid into a gas. The difference is whether or not it's just the surface molecules that are doing that or the whole substance, the whole sample that you have. So evaporation means that just the molecules at the surface are gaining enough energy to move into the gas state. Okay, so the rest of the substance isn't boiling, right? And this is what happens after it rains. There's water everywhere, and then the sun comes out and dries up all the rain because it evaporates the rain slowly. It's not a very quick process, and that we definitely aren't boiling the water that's on the surface, okay, or on the ground or forming the puddles or whatever. Boiling, however, is changing throughout the entire substance. So you're heating up the entire substance so that it's not just the surface particles that are escaping, but particles throughout the entire sample are gaining enough energy to turn into a gas. And so you start to see all those bubbles that are forming. Okay, so we'll look at that a little more in lesson 4 and really be able to distinguish between them. And then the last physical property of liquids is that they can form a solid. So in order for a liquid to form a solid, you have to remove heat, you have to freeze it, right? So we are removing energy, but all liquids do this. We usually think of like water freezing because water is one of the few substances that can exist as a solid, a liquid, and a gas on Earth. All substances can be in all 3 states, just not necessarily on the Earth. Some of them, the freezing point is much colder than we could do naturally on Earth, or their boiling point is much higher than we would naturally find on Earth. So different substances have different points at which they go through this. And again, we'll revisit that in lesson 4. Okay. So here we're showing diffusion. We have a beaker of water with some food coloring, and over time, those food coloring, the dye molecules, spread out throughout the entire substance, and eventually they are evenly distributed so that they have diffused. Okay, and that's the only one that I show. Okay. So that is actually the end of your notes. It's the end of the lesson. This one's really not very long. What you have today, you still have a homework, I believe. Okay, so you have some multiple choice, and then on the second page, you have some questions to answer. So make sure you're going back, use the book, use the video, whatever you need to do. You should be pretty soon doing a lab here on liquids. There's 3 parts to this lab, and I just want to kind of introduce it, go over it a little bit. So in the first part, we're going to be looking at viscosity, which is not a principle that your book covers, but it's an easy one to test, and it is a property of all liquids. So viscosity is this idea of resistance to flow. So some liquids pour out really quickly, some liquids pour out really slowly. So you're going to test 4 different liquids. You're timing how long does it take to pour 20 milliliters into a container. So you'll just have some cups and some graduated cylinders so that you can measure out 20 milliliters. You'll do each one twice. You can pour into the same container, it doesn't matter. And you're just going to time how long does it take for it to pour. So you're measuring out the same amount of substance each time, and then figuring out how long does it take. So your independent variable are your different substances, and then your dependent variable is the time that it takes for them to move or to pour. And you may not be able to get exactly all 20 milliliters to pour out. Sometimes they stick really a lot in the graduated cylinders, especially the corn syrup is going to stick. And then when you're done with this one, you can just stick everything, pour it all down the sink, wash out your graduated cylinders. Anything that seems like it should be washed, wash it out. Part 2 is evaporation. Alexa, off. So with part 2, you're going to have 3 substances: water, rubbing alcohol, and nail polish remover, and some cotton swabs. You're just going to swipe them on the desk or on the table, kind of observe what's happening as they evaporate. Okay. How long does it take for them to evaporate? And then just what happens. It gives you some things to look for in terms of what you should be observing. Do they spread out? Do they kind of curve or form little beads or what as they evaporate? And then part 3 is adhesion. Adhesion is different things sticking together. So you're going to have a couple of beakers. One of them is going to be full of water, and you're going to use some string to try and move the water from one beaker to the other. So you'll soak the string, you'll put the beaker with water on top of some books or something to make it higher, and then drape the string down to the empty beaker, and eventually you should see some water moving down the string, and you should be slowly, probably very slowly, filling the second beaker with water. And that's the idea. I don't know if it'll work. We'll see. All right, so that should be everything you need to know from liquids for now. Send me questions if you have them, and good luck.